Okay, we're live. This is going to be a bit of an experiment. Thank you, everyone. So the request was for me to try and film a lot of, well, the redox reaction stuff, the half equations. I'm over here. And what I'm going to try and do, I've put these slides up on Daymap. When I record it, it's going to be back to front. Again, this is an experiment. I'm going to see if it loads up and all that and trial with this video system, this swivel, they call it, because it swivels and follows me. So some of you might recognize Rowney uses this quite a bit. But what I'm trying to say is it's best to have the slides with you as I go through this method of balancing the half equations. Okay? So these are up on Daymap for you to peruse later on. I'll see if I can get the video up on Daymap if it works. I hope it's actually recording. If not, well, there's a timer. That's good. So it is on. Yeah, conditioner is on. Now what that means is I kind of need a bit of quiet while I'm, it's going to adjust to my sound levels, but I'm not sure if it adjusts to yours. I also want to get through this smoothly. So this will be my last run through of the redox stuff, and the rest I'll put into your hands. Later on this lesson, we are going to re-examine the acid batteries and the galvanic and electrolytic cells, okay? Josh, if you kindly stop clicking that pen, that would be awesome. All right, follow me. Thank you. So, if you've got your books out, rules for balancing redox pairs. There are 7 of them. And if you follow them nice and easy, step by step, logically, it all makes sense. And the reaction I've got for us today is we're going to react bleach or hydrogen peroxide with dichromate. Okay, and this dichromate is used quite a bit as an oxidizing agent. It's going to be reduced. This is the same chemical they use in breathalyzers. They oxidize the alcohol on your breath, and then the chromate is reduced, and they can detect how much alcohol you've had. Okay? But in this case, we are going to be oxidizing bleach, hydrogen peroxide. So first things first, balance for atoms other than hydrogen and oxygen. There are 2 chromate atoms here. All right? So first thing I'm going to do is make sure I've got 2 chromium ions on the other side of this reduction equation. Okay, if you actually look at the oxidation number of chromate, you'll find it's gone from, what do we got, a +6 to a +3. So it's been reduced. The next step, again, I add my waters to balance any oxygen atoms that might be there that aren't on this side of the equation or either side of the equation. So here my oxygen's balanced, so I don't need to add waters. But down here I have to add 7 H2Os because I've got 7 oxygens on that chromate ion. All right, so you get your waters down. Step 3. I now have hydrogens that are not balanced. So I'm going to put in some hydrogen ions. Over on this side, I've got the hydrogen peroxide. I'm going to need 2 hydrogen ions. And if I look here, I've added, from the water that I've added, I need to actually have 14 H+ ions on the other side of that equation. So what that means is that I've got now a charge overall on this side of +12. I've got a charge overall on this side of 2+. Okay? On this side of the equation, there's a 3+ charge. So now I have to think about how to balance the electrons. So how do we do it? Well, I balance the charge like so. Because this is the oxidizing reaction, I know that one of the products has to be electrons. So therefore, I put electrons on this side to cancel out that charge to get it down to neutral. So 2 electrons are going to be shaved off in that half equation. I know this is the reduction equation from the oxidation numbers. So I've got to put electrons into this system. I've got to get to, remember there's 2 chromium ions. So there's a +6 charge on this side and a +12 charge on this side. So what I'm going to do is I'm going to add 6 electrons to get it to where it's meant to be. Okay, 6 negative charges to get it where it needs to be on this side, which is 6+. Once I've done that, I can see I've got 2 electrons here, 6 electrons there. I'm going to have to balance this out. Okay, I've got to have to make the number of electrons in each half equation equal. So I'm going to times this whole equation by 3. Now it's a big number. Okay, that doesn't mean I change the small numbers by 3. I times each individual molecule and atom by 3. So what you get is something like this. Okay, I'm going to combine them, and I end up with 3H2O2, 14H plus, chromate. It's going to go to 3 oxygens, 6 H pluses, 2 chromium ions, and 7 waters. Note, you must cancel out any H plus ions or H2O molecules that appear on both sides of the equation. So now, once I cancel that out, I'm going to wind up with 8 H pluses rather than 14 because I've got 6 here that I can get rid of. And the rest is correct. So that's all balanced. And that's how you make a fully balanced redox reaction. All right, are there any questions on that still? I hope that works. Go over, look at my notes again. Just one more step I'd like to add before I turn this off. Okay, just check. You should always check. So check that the final equation is balanced for all atoms in charge. All right, if I look on the left-hand side, 14H plus, 2 chromiums, 13 oxygen atoms, 6 plus charge. If I look at the right-hand side, 14 H atoms, 2 chromium atoms, 13 oxygen atoms, and a +6 charge. Okay, both sides of the equation should have the same amount of atoms and the same charge because the electrons are just being transferred, and it must be equal. And I'll stop the recording there. I will hopefully load this up as a test and to see if it's actually worth me pursuing doing this constantly. I think what's going to work is if I give you the notes and then you follow along with my explanation.